Every year, the Earth produces one complete orbit of the Sun. While that implies already moving forward at lightning-fast rates, we're going to accelerate that speed now. Very up. Let's shrink the Earth to the size of a planet, spacecraft, and a crank up to the speed of light. Hello and welcome to KYC News. Please don't forget to subscribe and hit the bell icon. This is what would occur if the Earth revolved around the speed of light in the Sun. Okay, nothing moves more quickly than light. Prepare yourselves, then, because moving through space is light. Incredibly fast 300,000 kilometers per second, 186,000 miles per second. Hence, starting with the instant a light particle departs from the Sun, hurtling earthwards in your direction, it only takes 8 minutes before it slams onto your face or delicately touches your face. Yes, it just takes 8 minutes in all to cover 150 million kilometers, 93 million miles. Also, moonlight refracting light, the time it takes to reach your eyeballs is really brief. Now, with regard to a thing as one accelerates to the speed of light, nothing is as easy as it seems, as accelerating the pace. Take our globe, then. As the speed of light approaches, ultimately, as its bulk rises, it goes on forever. Moreover, to move indefinitely hefty item, you will require an endless supply of energy. And that is simply not doable. Before now, the Sun already orbits the Earth at 19 miles per hour, 30 kilometers per hour. While that's certainly not sluggish, similar to the speed of light, and even that is only a drop in the ocean. In order to be more specific, this enormous burning ball orbits the Earth at a speed of just 0.01% of light. Hence, there is a lot of ground to cover. So don't go too far in advance. As a result, even if we only increased orbital velocity of the Earth to 26 miles per hour, 42 kilometers per hour, we would be in grave peril. Due to the fact that at this speed, the planet would reach its orbital escape speed, hence, it would be moving quickly enough to escape the gravitational pull of the Sun. We would only be venturing into space. Yet another icy, hostile planet without a home star system to return to. We would traverse the solar system, of course, before being permanently expelled from it. Around 3 years later, because of its rapid movement, we would travel to Neptune. Then, we would have already overtook all other worlds outside of the solar system. If we were truly unlucky, Earth might collide with the large gas ball. Jupiter will follow. Just a moment, that would make for a nice vista as we got closer. But how unfortunate that it wouldn't endure enough time for you to appreciate. A result of Earth's collision with Jupiter would have some deadly consequences. But we wouldn't permit your epic sudden conclusion to the adventure. In this case, Earth would continue to fall beyond the solar system, too. We would keep accelerating faster and faster out of the confines of our world and into the vast uncharted. And without the heat of the Sun, Earth would eventually, albeit gradually, become a lifeless, cold rock. Okay, that definitely didn't go as expected. So how about we begin again? Break the rules of physics and maintain Earth in the Sun's as it approaches light speed orbit. How does that sound? To speed up the whole globe to such a phenomenal speed, we would require a lot of power. The amount? Well, more than you may anticipate. Even if you were to try to speed up 90% of the speed of light, at most, you would require as much power as the world's population eats in 5 days. Thus, where in the cosmos would we are able to replenish our energy? To accelerate the entire planet? Your best option would be to follow the example of a very uncommon but a star that moves very quickly. A star with high speed. These stars have velocities of up to 33% of the speed of light or faster. There may only be 1,000 of these types of stars in our galaxy as a whole, all because they require a special sequence of events to take place first. Accelerated stars approach there by orbiting a black hole at hyperspeeds that is hitting another black hole in a collision. These two abysses start a mutually beneficial dance, increasing rate of rotation before finally letting go. Also, that gravitational disruption which results in stars being scattered throughout the universe at such irrational speeds. Well, so it's not difficult. For us to get there, the light speed, all we need to do is swing surrounds one or more black holes. What is the worst possible there could take place? Currently, traveling at the speed of light on Earth, not exactly like what you observe in movies when using the Millennium Falcon, the USS Enterprise starts its engines. To begin with, you wouldn't observe any of the night sky contain more stars. That's because you would be going through the so-called Doppler effect. In terms of science, every light source pointing toward Earth would now occur more frequently, leaving the obvious spectrum all the way to the X-rays. In a nutshell, the star's illumination would becoming undetectable to you because X-rays are invisible to the human eye. And it can indicate a hidden threat to your safety. X-rays may result in a variety of health issues and raise your chance of getting cancer. While the atmosphere today is sufficiently dense to largely prevent this radiation, stars that have reached us traveling as quickly as light may put the environment to the test. Yes, we might lose our air shield of defense, which also implies that on Earth that it would prevent you from breathing. Even when the atmosphere managed to remain in place, moving at the speed of light would damage it soon. Even the smallest thing, like a hydrogen molecule, would grow to be a terrible risk. Hitting our atmosphere with a bang at such high speeds, it might boil it to death. And I doubt that you would appreciate being on Earth if the atmosphere suddenly disappeared. But that's another tale. A second what if. The Earth also rotates on its axis and revolves around the Sun, like other planets. Currently, the Earth rotates at a high speed of 1,000 miles per hour. Despite this, we don't feel anything, which means it doesn't affect us. But even a slight change in the rotation speed would affect us. So, can you imagine what would happen if this speed will increase to the speed of light? How will it end life on the Earth? The understanding of the relativity and speed of light will help us to understand the destruction that could happen. Theory of relativity and the speed of light. Theory of relativity. Einstein's special and general theory of relativity has given a few postulates and mathematically expressed as Lorentz transformations. Einstein stated that the physical quantities like the mass, the energy, the time, and the length vary if we approach the higher speeds in an accelerating frame. He also proposed that the speed of light in a vacuum, the fastest, is the same for all reference frames. The speed of light. The speed of light is the speed at which light waves propagate. In the vacuum, it is a constant, which is equal to 3,108 meters per second. The electromagnetic radiations and gravitational waves also travel with this speed. An object must have zero rest mass to achieve the speed of light. The relativistic mass, m, will become infinite with zero rest mass. Even if the object has mass, the relativistic energy has to be infinity. So, the relativistic mass will also be infinite, in which infinite mass implies that the object is traveling with the speed of light. It is something that Einstein's mass-energy equivalence says. If the Earth rotates at the speed of light, such a drastic change in the rotational speed would definitely lead to catastrophic results. Life would no longer remain, and it would be an end of the Earth. The theory of relativity explains some of the things that could happen. Length contraction, Earth would seem like a fine line. When an object approaches the speed of light, the original dimensions contracts to a smaller size, called the length contraction. Similarly, the dimensions of the Earth would contract to form a disc-like structure with negligible thickness, appear as a thin, single-line structure. It doesn't mean that only Earth would affect. All the living and non-living objects, including you and me, would contract like this. For the observer outside the planet, he would see the Earth to orbit the Sun tangentially, disturbing the geographic conditions. Thus, life on Earth will die.